Hey all you cats and kittens, it's time to get back to some chemistry. And we can't do chemistry unless we started out with a great joke. So here's a good one. What kind of fish is made out of 2 sodium atoms? A tuna. Ha ha ha, that one was a good one, right? Tuna, get it? 2. And then Na is sodium, so na, so a tuna. Yeah, if you have to explain it, it's not as funny, right? So anyways, how y'all doing out there? Since we left off, let's see, we've been learning about acids and bases. You guys did like a little simulation. What we're going to talk about right now is neutralization reactions and titration problems. Sounds fun, right? So you watched a video that kind of talked about neutralization reactions and just quickly went over it and talked about how the pHs, depending whether it's strong acid, strong base, and all that good stuff. What we're going to do is get into the nuts and bolts of it. We're going to look at first, how can you tell just by looking at it whether it's an acid or a base and being able to identify. That'll be a little review for you enriched chem people, but bear with me. And then we'll get into how you do titration problems. So in that way, you can go ahead and you can do the actual titration lab and you'll be able to do well on the quiz as well. So let's start with looking at how do you know if it's an acid or a base. So acids are ionic compounds that start with H and they're AQ. So really how they're made is they take a gas and they bubble them underwater, and as a result they turn into an acid. So if you think of pop, soda pop, the reason that it fizzes and it has bubbles is because it has carbonic acid in it. So what they do is they take CO2 gas, and then what they do is they bubble it into water, and as that process happens, it becomes acidic, and that's how you get your nice bubbles in any of your carbonated drinks. So let's look at an example here. If we have H2S, H2S as a gas is just called hydrogen sulfide. Once we dissolve it in water, so we take that gas and we bubble it in water, so some of it is dissolved in water, it becomes a Q. It is no longer a gas. Well, it's a gas, but it's a dissolved gas. It is no longer just an ionic compound. It is now considered an acid, so its name changes. Standard kiddos, you don't have to worry about understanding how to name stuff enriched. You already did that last week. So this would be called hydrosulfuric acid. So if you see a name and it says acid in it, then you know it's an acid. By looking at the formula, the way you know it's an acid is it starts with an H. It's an ionic compound, so it's made up of 2 ions, and it's AQ. Bases are a little easier because anything with hydroxide as the anion is a base. So if you look at a formula and it's got OH as the polyatomic ion, or if you look at the word and it ends with hydroxide, you've got yourself a base. Now there are other bases like ammonia, and unfortunately because we're doing online and we're not doing actual class, we're kind of giving you the cliff notes when it comes to what's going on. So you'll learn more about ammonia if you move on, and you'll learn more about it in like bio and so on. So let's look back at those neutralization reactions. You already watched a video and answered some questions that kind of went over this. So quickly, a double replacement reaction. It's a special type because it forms water and a salt. So it's always going to start with an acid and a base as the reactants. What you need to be able to do is look at those reactants and be able to say, whoa, that's an acid or that's a base. And you can do that just by looking at the formula, or the name will tell you. So if we look at our very first one right there, if we look here, we've got calcium and hydroxide. Well, we just learned that anything with OH in it is a base, so we would say that this is your base. You can tell just by looking at it. Now let's look at our second reactant. So the 2 requirements to be an acid are it starts with an H and it's an AQ. So this would be our acid. So when you see OH, you can say that that's a base. When you see a ionic compound that starts with H and has an AQ on it, then you know that you've got an acid. So let's say these 2 react. This is no different than what you've been doing this whole time when it comes to double replacement. Outside ions go together, form a new compound. Inside ions go together to form a new compound. But what's a little bit different is that one of these is going to end up being water, because we learned before that when you take hydroxide and H, hydrogen, the ions, and we put them together, they form HOH, which is water. So, and we already learned that that is going to be a liquid. So, when you mix an acid and a base together and there's a neutralization reaction, one of the products is going to be water. The other product is called a salt. All a salt is, and we've said this a few times, it's a term that just refers to an ionic compound. So now the calcium and the chloride are going to come together and form your salt. And again, just like we talked about before, we look at the charges, we put the positive followed by the negative, and that's what determines what our formula is. So calcium is our metal. It's listed first because it's positive. Chloride is our non-metal. It's listed second because it's negative. If we look up our charges, calcium is a +2, chlorine is a -1. So if we cross our charges, it's going to be CaCl2. And in terms of its state, if we look at our solubility rules, Cl is a halide, which is going to be AQ unless it's with lead, mercury, or silver, which calcium isn't. So this is going to be AQ. And then our last step is we need to balance the entire thing. So if we go and we look, we've got 1 calcium and 1 calcium. We've got 2 hydroxides. Now when we were learning how to balance, I talked about this a lot, how you think about this as H and OH separately. So if we think about that, there is a 2 here with the OH. So that means we have to put a 2 here in order to balance the OH. And then if we look at our chlorine, we've got a 2 on the right side, and we only have 1 on the left side, so we're going to have to put a 2 on the front of that. And then that also balances our hydrogens because this goes ahead and distributes everything behind it. So I'll just clean this up quick. So our overall reaction would be calcium hydroxide, which is our base, reacting with 2 hydrochloric acids. And then as a result, we're going to end up with 2 waters. Water is always going to be liquid in these reactions. And followed by our, in this case, our aqueous calcium chloride. Now we're going to shift gears a little bit, and we're going to look at neutralization. So you looked at that in the video, but now we're going to go into how that relates to the math and how we solve what are called titration problems. So we learned that neutralization happens when the moles of hydrogen ions is equal to the moles of hydroxide ions. Now what's interesting is if we think back to concentration when we learned about molarity and we learned how to figure all this stuff out, if we take molarity and we multiply it by volume in liters and we look at the units and we cancel out the units, so this is in the denominator and this is in the numerator, so those two cancel, notice that it cancels out to just moles. So molarity times volume in liters always equals moles. So if you think about it, molarity times volume equals molarity times volume would be the same thing as saying moles equals moles. And so if we want moles of H plus to equal moles of OH, that's how we came up with the titration equation. So here's our titration equation. Molarity of acid times volume of acid equals molarity of base times volume of base. So big M is molarity, V is volume, A stands for acid, and B stands for base. Now what's nice about this is that if you are using the same volume, so let's say you're using milliliters for everything or liters for everything, you don't have to sit and convert those volumes to a particular volume because it's going to end up canceling out because you're comparing them to each other. So let's look at how one of these problems happens. So in this problem, sorry, my little thing's in the way. So in this problem, we've got 45.6 milliliters of a 0.12 molar solution of HCl. HCl is hydrochloric acid. So that was needed to neutralize 34.5 milliliters of sodium hydroxide. What is the concentration of sodium hydroxide? Concentration, if you remember, means the same thing as molarity. Concentration is just a general term, but we said that we were going to work in molarity when it came to concentration. So what do? What we do is we use our equation that's listed up above there, put all our numbers in that we have, and solve for x. So if we look, we've got HCl. HCl is an acid because we learned that it starts with an H. And so if we fill in our numbers for molarity of acid is going to be equal to 0.12. Our volume of our acid is going to end up being 45.6. And then if we look at molarity of base, that's what we don't have. That's our X. That's what we're trying to solve for because we're looking for concentration of sodium hydroxide. And then we have our volume of base, which is given to us as 34.5 milliliters. So now it's a matter of plugging our values in and solving for the missing variable. So I'm just going to go ahead and plug these in so you can see it. So 0.12 and volume of acid is 45.6, which is going to be equal to our X, which we don't have. That's our molarity of our base, times our volume of our base. So just like in algebra now, we want to get x by itself. So in order to get x by itself, we have to divide both sides by 34.5. 34.5 is going to cancel with 34.5. So if we go ahead and plug in chug, we're essentially multiplying 0.12 by 45.6. That answer is getting divided by 34.5. And if we plug and chug that into our calculator, we're going to get 0.16 if we round to 2 decimal spots. And it wants to know concentration. Concentration is molarity, so I'm going to label this with a capital M. So that is my answer to that problem. Here's another one. Instead of molarity now, it's asking how many milliliters of a 0.5 molar NaOH, sodium hydroxide is the name of that, are needed to neutralize 25 milliliters of a 0.18 molar HCl. So again, we've got our base right here. We know that because it's got OH in it. And here is our acid. And we know that because it starts with H. And then we're going to use our equation again, fill in what you know, solve for X. So if we look, molarity of our acid is going to be 0.18. And then we've got our volume of our acid, which is 25. So that's our MA and our VA. And then on the right side, we've got our molarity of our sodium hydroxide, which is the same as our molarity of our base. And then we don't know what the volume is. That's our X. That's what we're trying to solve for. So we've got molarity of our base, and we've got volume of our base. So again, we're solving for X. So to get X by itself, what we're going to be doing is just taking and dividing both sides by 0.45. And so we'll just do like this. Both sides divided by 0.45. Cross those out. And then if we go ahead and we take 0.18 times 25, divide that number by 0.45, we should get 10. So what's my label? Question is asking how many milliliters. And so this would be ml for our final answer. One last example. Sometimes your acid and bases have more than one hydrogen or hydroxide ion in the formula. When that is the case, we have to add to our formula. So if we have more than one hydroxide in our formula, we have to put how many on the base side. Or if we have more than one hydrogen, we have to put how many on the hydrogen side. So it's just like we did before, except we're going to have to add a number there if there's more than one. So let's look at an example. What is the molarity of a 25 milliliters of HCl, so hydrochloric acid? We know that this is the acid because it starts with H. That was neutralized by 65 milliliters of a 0.15 molar solution of calcium hydroxide. We've got hydroxide there, so we know that that is the base. But look at our base. There is a 2 subscript here. That means that we actually get 2 hydroxides for every formula. So what we need to do is we are going to have to add that. We're going to have to put a 2 up here in that spot because there's more than one. So the only time you have to do that is if your formula has more than one. So we're going to go ahead and put our numbers in again, just like we did before. It's asking for the molarity of the HCl. So we don't have molarity of acid, so molarity of acid is going to be an X. Notice that number of hydrogen would just be 1, so you can put that in if you want, or I'm just going to leave it out. Then we have 25 milliliters of it. Now if we go over to the base side of it, we have 0.15 is our molarity. It's right there. And then we have 65 milliliters. But now we're going to add a 2. So that 2 comes from the fact that there are 2 hydroxides in that formula. Just like before, we're solving for X. And so we want to get X by itself. So what we're going to be doing is dividing both sides by 25. So 25 ends up canceling out. So we're going to take 0.15 times 65 times 2, and whatever that answer is divided by 25. And then we're going to round to 2 decimal spots, and we're going to come up with 0.78 capital M because it's asking for molarity. So that's pretty much it in a nutshell. You just need to be able to look at your reactants, be able to tell by the formula whether they're an acid or base. Do crisscross applesauce and insides outsides for the double replacement reaction to write your 2 new products. One of them, if it's an acid-base reaction, is going to be water, and so that's going to be a liquid. You'd use your solubility rules to determine whether the other salt or the other product, which is going to be a salt, is aqueous or solid. And then we just looked at the titration equation, molarity versus volume. And so you'll also get some more practice with that with your lab. And that's kind of going to be what your quiz is going to be in a nutshell. Sorry, I kind of said that like 6 times. You're going to need to be able to write the new products or recognize the new products, and you're going to have to be able to use that titration equation. As always, if you have any questions, make sure you shoot me an email. If there's not a Google Meet set up, I'll set one up for you so that we can get together and go through this stuff. Have a great rest of your week. Hope all is going well. Bye-bye.